Hello and good morning. Let's take a look. We have the EOCs next week, and for geometry and MCR, it will count as a grade, a midterm grade, and the county for geometry will figure out the grade there. Let's take a look here. If you didn't already get your 3 pages up in the front by the file cabinet, by the Cheetos box, 3 pages. Let's take a look here. All right, so number one, it says, given that line XY and this one intersect at point A, what conjectures are always true? Well, you know that two lines always intersect at a point, one point, XY, and let's just draw this up, ZW, and then point A is where they intersect. Okay, so what conjecture? XA is always equal to YA or AY. Well, if it intersects at a point, it doesn't mean it's a midterm or a midpoint rather. So I would scratch that out. It doesn't say midpoint. Angle XAZ. XAZ is this angle, is acute. I mean, it could be, but it doesn't have to be. Is it perpendicular? No, I wouldn't say that. I mean, it could be, but it's not. It doesn't say that. XYZ and point W are non-collinear. That one's true. Okay, non-collinear means not in a straight line. So that's the only one that's always true. Make sure you go through each one of these and reason it out. Oh, excuse me, let me make it a little bit smaller. Okay, so let's keep moving. Number two, the figure shows line R, N, and P. So R, N, and P. Make sure you look at the diagram as you're working, okay? Intersect to form angles 1, 2, 3, 4, etc. All three lines lie on the same plane. Based on the figure, which of the individual statements provided enough information to conclude that R is perpendicular to P? So R, you want perpendicular to P. So let's see. Select all that apply. Well, if the measure of angle 2 was 90 degrees, that would make angle N perpendicular. So I'm not going to go with that one. If angle 6 is 90 degrees, then I'm going to definitely say that would be a yes. If angle 3 was equal to angle 6, just because they're equal doesn't make it perpendicular. So I'm going to say no on that one. The measure of 1 plus 6 equals 90 degrees. 1 plus 6, if you add those two up, it would make N perpendicular, not P. And then 3 plus 4, let me see that one. 3 plus 4, if that added up to 90, that would make N perpendicular. And that's not the one we're shooting for. Let me just verify that. Make R perpendicular to P. And we're shooting for R. Okay, and then 4 and 5, 4 plus 5. If 4 plus 5 was 90, then definitely R would be perpendicular. I'm going to go with those two right there. All right, let's keep moving. Which of the following is true? Well, what I would do first is add up my distances. 1, 2, 3, 4. So this one is 4, 1, 2, 3. This one is 3, and this one is 1. One space. So let's see which ones are true. AB plus BC. So AB plus BC is 7, and AC is 7. So yeah, that's segment addition. I'm going to say true on that. On the next one, CD plus AB. So CD is 1, and AB is 4, so that equals 5. And they're saying BC. BC is only 3. I'm going to say no. CD is 7 if you add these two up. So I know it's 7, and then 1/3 of AD. AD is 4, 5, 6, 7, 8. If I take 1/3 of that, 3 doesn't go into that, but 2 times. I'm going to say no on that one. This one right here, let me think about it. Half of AB, so AB is this one. So half of AB, half of 4 is 2. So I get 2. I think that's a minus. So these get kind of weird. CD minus BD. So CD is 1. So 1 minus BD. It's kind of hard to read, but I'm going to say that's 4. Okay, and then I'm going to divide by 2. So that gives me a negative 3 over 2, but I had a negative here, so that's going to be a double negative 3 over 2. So let's see what happens. Half of AB was 2. We know that. All right, so on this one, it looks like I get a positive of that, and then I'm dividing by 2, and when you divide, you got to flip it over. I don't think that one's going to work. You might want to redo it to check it. This one right here is 1/3 of AB. AB is 4, so 1/3 of 4, you put a 1 under here, and that's going to be 4 over 3. So we're trying to get it equal to 4 over 3. So CD is 1, so let's put a 1, minus BC. BC is 3, and then divide it by 3. That right there is a negative 2 over 3. I'm not saying that one's going to work either, so I'm going to X that one out. They're kind of hard to read on that, but you just got to stay with it. Okay, let's keep moving here. Read that one right there while I look at something. All right, so let's take a look. It says, given that the measure of ACF was the whole thing. So given that the whole thing is 70 degrees, if the measure of ACB is 16, so put a 16 for this one. And notice that this one right here has one stripe and this one has one stripe, so put a 16 right here. I know it's hard to read, but I think you can. ACB is 16, so ACB, we already got that one. What is the measure of BCD? BCD is this one right here. That's the one we want, but it's equal to this one, okay? So what we want to do is take 70, and we want to subtract 16, and whatever we get is going to be this whole thing, but we don't want the whole thing, we only want half of it. So we're going to take 70 minus 32, press equals, and then split that in half, and I get 36. So I'm going to say this one right here is 36 degrees, and that's the one they want, BCD. And this one would be 36 degrees as well. And there we go, and that's how you do it. All right. Number 5, what is the best description of acute angle? An acute angle is less than 90. It's between 0 and 90 degrees. Okay. So an acute angle would be somewhere in this region here. Okay. So an angle measuring more than 90 degrees, no, that would make it obtuse. An angle measuring more than 90 but less than 180, no. An angle measuring between 0, more than 0 but less than 90, I'm going with that one. An angle measuring less than 0 would be a negative, we don't want that one. And there we go, and that's what acute is, and that's purely a definition. Let's keep moving. This one right here, what is the name of this ray? So we're going to put ray BA, and then we're going to intersect it with BC. And what's the name of the angle? Well, you can go ABC, you can go backwards, CBA. In this case, you could just name it angle B. Let's see which one they have. So I'm looking for ABC, And there's ABC right there. That's the one I'm going to go with. But what you should do is read them all, okay? Because this is a very important test. Point P is this one, is reflected over this line, x equals -3. So this line right here is 1, 2, 3. X equals -3. So if you want to reflect it over that line, you have to count your spaces. So watch what I do. I want you to do it too. So 1, 2, 3, 4. So you want to go 1, 2, 3, 4. So this is the new point right here. And then the resulting point is reflected over this line y equals x. Now go perpendicular. 1 space and a half. Perpendicular. 1 space and a half would be right here. That's your answer. So start at 0, 0. So 0, 1, 2, 3, 4, up 1. I'm going to say 4 and 1. And that's my point right there. And notice how, I don't want to say tricky, but they're just testing you. Okay? So first, you reflect it over this line, and then you reflect it perpendicular to that line, y equals x. Remember, y equals x, you switch them. Say that to yourself so you memorize it. Let's keep moving. Given this point and that point, and this point and this point, what did they do? So in other words, they went from -3, and then the x went to -1. The y went from -1, and then it moved over to a +2. So the question is, how do you go from a -3 to a -1? Well, you would have to add 2. So this would be a +2 right here on the x. And then the y, to go from a -1 to a +2, let's see what that is, -1, 0, 1, 2. So to do that, you'd have to go 3 to the right. So I'm going to say a +3. I'm looking for 2, 3. You'd have to add 2 and add 3. I'm going with that one right there. But again, you should always reread the problem, okay? Let's go to this one right here. Point F is the image, F prime is the image of F. It's reflected over this line. So let's see how that line looks. This is your x, -1, -2. Remember, put the tick marks, okay? You got to know what that line right here looks like. And then it's reflected over y equals 3. So 1, 2, 3 would be right here. That would be y equals 3. Okay, so let's see here. The location of F prime is this. So you want to go over 3, 1, 2, 3, up, 1, 2, 3, 4, 5, 6, 7. That is the result here. Okay, that is the image. So they want to know what happened before. All right, well, let's see. First, they reflected it over this line, and then they reflected it over that line. Okay, so this line, y equals 3, is here. So you're going to go backwards. Okay, so I'm going to go 1, 2, 3, 4. Then I'm going to go 1, 2, 3, 4. It would be here. And then they reflected it over this one. So I'm going to count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I hope that's going to be my answer. So that's 1, 2, and then 5. So that would be a -7, right? And then you're going to go down. It looks like, oh, I don't know, down 1 might be right here, down 1 from the x-axis. So I'm going to go with this one right here. That's my choice. Okay, so you got to think backwards on this. Let's keep moving. I'm only going to do one more here, and then I'm going to stop for today and pick up tomorrow. So look here. Triangle blah 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 is rotated 90 degrees about the origin. So there's the origin, and you're going 90 degrees. Okay. Now let's see, and then it's slid over. It's translated here. All right. So here's your triangle, and you want to go 90 degrees. So what I would do, you should know your rules. But let's say you don't. So look at point K, for example. If you take point K and then you go 90 degrees, 90 degrees is going to look something like this. So if you go 90 degrees here and you put the circle, it looks like it's going to hit right there. Okay, is what I'm going to say. So I'm going to say over 1, down 1 would be k prime. Okay, and then I want to go -8 on my x, and then I want to go a +5 here. So the new prime, or the new point rather, it looks like a -7 and 4. And that's what I'm looking for. And you can see I don't actually see it. All right, so what we need to do actually is know the rules. So let me look up at the board here and see what it is. So we got reflections, and I don't see the rotations, okay? So you're going to have to look up the rules for rotation. So let's see, 90 degrees about the origin, and they don't say clockwise or counterclockwise, so we're going to assume